All right, today we're going to dive into a really cool, almost kind of magical connection between two things you'd probably never, ever think to compare. A 3D pyramid made of spheres and a simple, flat 2D grid. So what could they possibly have in common? Let's jump in and find out. So here they are. On the one hand, we've got this pyramid of colorful balls. You can practically imagine holding it, right? It's a physical object. And on the other hand, something totally different. A flat, black and white drawing of a 5x5 grid. One's a thing, the other's an idea.
And that's the big question, isn't it? What on earth is the link here? One is all about stacking and building, and the other is about counting abstract shapes. But as you're about to see, there's this incredibly elegant mathematical thread that ties them together. It's awesome.
Okay, so to crack this, let's treat them as two totally separate puzzles. We'll start with the pyramid. And the question is pretty straightforward. How many little spheres does it take, in total, to build this thing 5 layers high?
You know, the easiest way to get an exact count without missing any is to just take it apart. We'll look at it layer by layer, starting right from the tippy top and working our way down to the bottom.
So right at the peak, we've got, well, just one single sphere. Easy enough, right? That's a count of 1.
Okay, moving down one level. The next layer is a perfect 2x2 square. So 2 times 2, that gives us 4 spheres.
And if we follow that same logic, the third layer down is a 3x3 square, which means 9 spheres. I bet you're seeing the pattern now, right? Every single layer is a perfect square number.
Yep, the fourth layer is a 4x4 square, giving us 16 spheres.
And finally, the base, the biggest layer of our pyramid, is a solid 5x5 square, and that's made of 25 spheres. So to get the total, we just need to add up those first 5 square numbers. 1 plus 4 plus 9 plus 16 plus 25. But you know what? Let's put a pin in that for just a second and switch gears to our second puzzle.
All right, now for the grid. The question here is totally different, but just as fun. How many squares of all possible sizes can you find inside this single 5x5 grid?
Now, I know the temptation is to just start pointing and counting randomly, but trust me, that's a surefire way to get it wrong. The best way to do this is to be really systematic. We'll count all the tiny 1x1 squares first, then all the 2x2s, and so on all the way up to the big one.
Okay, let's start with the most obvious ones, the little guys, the 1x1 squares. We've got 5 rows and 5 columns, so that's just 5 times 5, which gives us 25 of them. Simple.
Okay, what about the 2x2 squares? Well, think about where you can place one. It can be in 4 different spots horizontally and 4 different spots vertically. So, 4 times 4 gives us 16 of those.
And hey, the pattern just keeps on going. For the 3x3 squares, there are even fewer places they can fit. Just 3 positions across and 3 down. So 3 times 3, that's 9 of those. For the bigger 4x4 squares, you've only got 2 possible starting spots across and 2 down. So that's a total of 4. And of course, the biggest one of all, the entire 5x5 grid itself, well, there's only one of those. So, if we add all of those up, the 25 little ones, the 16 2x2s, the 9 3x3s, the 4 4x4s, and that one big one, we get a grand total of 55 squares.
Okay, we did it! We solved both puzzles. We know how many spheres are in the pyramid. Well, we know the sum, and we know the grid has exactly 55 squares. Now, let's bring those two results together. This is the good part.
Just look at this. On the left, that's our sum for the pyramid spheres, 1 plus 4 plus 9 plus 16 plus 25. And on the right, the sum for the grid squares, 25 plus 16 plus 9 plus 4 plus 1. It's the exact same set of numbers, just in reverse order.
And both of them, of course, add up to the exact same answer, 55. Isn't that wild? One problem was about physically stacking balls in 3D. The other was about counting abstract squares in a 2D drawing. And yet, mathematically, they are identical.
This number, 55, isn't just a fluke. It actually has a name. It belongs to a special set of numbers called square pyramidal numbers. And what are they? They're literally the sum of the first n square numbers. It's exactly what we just found.
So, okay, besides being a really cool piece of trivia you can use to impress your friends, why does this connection actually matter? What can we really take away from this?
Well, what's so amazing is that this relationship holds true for a pyramid or a grid of any size, and mathematicians have captured this beautiful pattern in a single, elegant formula. You don't have to worry about the crazy notation. The main idea is that it's a shortcut. You could figure out the spheres in a 100-layer pyramid in a snap, without adding 100 numbers.
So you see, this is way more than just a party trick. It's a perfect example of how to think like a mathematician. It forces us to be systematic so we don't make mistakes. It shows us how a physical, geometric problem can be the exact same as an abstract algebraic one. We learn how to see patterns of units inside of other units, and really, it's a gateway. It gets us asking deeper questions, which is what discovery is all about.
And that's the real magic here. It leaves us with this final, really fascinating question to think about. What other profound, amazing connections are just out there, hiding in plain sight in the simple patterns that are all around us every single day?